Good day, everyone. In our previous topic, we discussed about finding limits of a function using numerical investigation or table of values. We also use laws or theorems to find limits of a given function. And then we emphasize that for a limit to exist, using both values from the left and from the right of A, there must only one limit. Now, how about if we are given a function like f of x, okay? So what if we are given a function like this? F of x is equal to square root of x minus 2. Then we are asked to find the limit of f of x, okay, as x approaches to 2. Okay, so another notation for this limit of f of x as x approaches to 2 is find limit of f of x as x approaches to 2. Okay, this is another way of writing the limit of a function as x approaches to 2. Now, how to find the limit of this function? Now, technically, we have to find the domain of this function first, because technically we only consider the values of x from the right of 2. Why? Because the domain of f, okay, what's the domain of f? The domain of f is, meaning f of x is defined, okay, if what? If what? If the x minus 2, okay, x minus 2 must be greater than or equal to 0 for this function to be defined, okay? So we have to solve for x. So x must be greater than or equal to 2. In other words, this function is defined only if x is greater than or equal to 2. So, which means that the limit of this function, we only consider the values from the right of 2. Because if we consider values from the left of 2, this will be undefined. Okay? So technically speaking, the proper way of finding the limit or writing the limit of that function is limit of f of x as x approaches 2 from the right. Okay? So, how? Now, later on, we will understand what is this notation, kung ano po yung ibig sabihin ng notation na ito. Okay? So, later, we will know what's the limit of this. What do you think? What do you think is the limit of this function? The limit of that function, given a specified domain, so we can also write as limit of f of x as x approaches to 2, okay, is equal to what? We just simply substitute 2 to the variable x. So we have 2 minus 2 is equal to square root of 2 minus 2 is 0, is 0. Therefore, the limit of this function as x approaches to 2 is 0. But again, the proper way of understanding the limit is only the right-hand side of this value. We only consider the values from the right of 2. Okay? So it's 0. Now, so this is a good example of starting a topic which is about one-sided limit. Okay? So, one-sided limit. One-sided limits, we have to consider this example first. Okay, earlier we considered the function f of x is equal to the square root of x minus 2. This time, we have another function, and this function is what we call the Heaviside function, and this is denoted by h. So this function is given by this equation. Now notice that the Heaviside is a piecewise defined function. What do we mean by piecewise defined function? This is a type of a function that consists of two or more expressions, okay? Expressions or equations over a specified domain, okay? So, for example, in this case, we are given a function, the Heaviside function h of t. Now, h of t, meaning is a function of t, okay? There are two values of h, 0 if t less than 0. So which means the value of h is 0 if t less than 0. Meaning, ito lang po yung value ng h, 0, kung itong condition na to masatisfy. Which means, if t less than 0 only. And 1 if t is greater than or equal to 0. So, the value of the Heaviside function is 1 kung masatisfy ang condition na ito. So, this is a piecewise defined function. A function consists of two or more expressions over a specified domain. Because the domain in this case is specified. In this case, 0 if t less than 0. 1 if t greater than or equal to 0. Okay? Now, to understand more on the Heaviside function, let us graph this function. Okay? What do you think is the graph? The graph is this one. Okay? So, the graph of h of t is 0, okay, 0 if t less than 0. So 0 if t less than 0. So we are considering the values of t here less than 0. But notice that it's a circle, a hollow circle. So circle siya. Hollow. Why? Because t is not included here. So t excluded, but it is 0 if t less than 0. Now, so these are the values of t less than 0. So we expect that the values of t here, 0 and to the negative infinity. Now, 1, so notice it's a shaded circle. Okay, shaded because t equals 0, meaning it is 1 if t is greater than or equal to 0. So you locate the values of t which is equal to 0 up to positive infinity. Okay, so this is the graph. Notice that this is a constant function, right? 0 if t less than 0. 1 if t greater than or equal to 0 is a constant, and recall the constant function is a forms a horizontal line. Okay? Now, what another question. What do you think is the limit of h of t? So this function here, okay? What do you think is the limit of h of t as t approaches 0 from the left? So, you have to consider the values of t from the left of 0. So, where are the values of t from the left of 0? This one. Okay? These are the values of t from the left of 0. Okay? Now, saan siya mag-a-approach? As t approaches 0 from the left, so 0 from the left, okay, y value approaches to what value? It approaches to 0, meaning as t approaches 0 from the left, the y value approaches to 0. So that is the limit. Limit of h of t as t approaches 0 from the left is 0. How about this one? Limit of h of t as t approaches 0 from the right. So that's why we consider this as one-sided limit, class, because we consider first the left-hand side and the right-hand side. So how about this one? The limit of h of t as t approaches 0 from the right. Okay? So 0 from the right, so you consider as t approaches 0 from the right. So these are values of t from the right, right? Of 0. So 0 from the right, it approaches to what value? It approaches to 1. And that is the limit of h of t as t approaches 0 from the right. Now, what have you noticed? What's your observation? Maybe you observe that the limit of h of t as t approaches 0 from the left is 0, which is not equal to the limit of h of t as t approaches 0 from the right, right? Because it is 1. So the left-hand side limit is not equal to the right-hand side limit. So therefore, what do you think is the limit of h of t? What do you think? Okay, the limit of h of t as t approaches 0 does not exist. It does not exist because there is a theorem that for a limit of a function to exist, the left-hand side limit must be equal to the right-hand side limit. And in this case, we have the left-hand side, which is 0, which is not equal to the right-hand side limit, which is 1. Therefore, the limit of h of t, okay, h of t as t approaches 0. 0 na lang siya. So, does not exist. What's the reason? Because, so you put a reason, because the limit of h of t as t approaches 0 from the left is 0, and limit of h of t as t approaches 0 from the right is 1. Okay? Which means that 0 is not equal to 1. Therefore, ito na yun. Therefore, limit of h of t as t approaches 0 does not exist. Okay? Okay. So next is this one. We have the definition of one-sided limits. So we write the limit of f of x as x approaches a from the left. So this symbol here means that we consider the values from the left of a. Okay? So limit of f of x as x approaches a from the left is equal to L. And say that the limit, so we say that as the limit of f of x as x approaches a from the left is equal to L if we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to L with less than a, x less than a. Okay? So assuming that we have what interval, tapos we have a here. Okay, so we consider the values of x going to a from the left and x going to a from the right. Okay, so this is what we call the left-hand side limit. In other words, this is an example or a definition of one-sided limits. Okay? Okay, so next, we have an important remark. Notice that definition 2, the previous definition, differs from definition 1. What is definition 1? It's the definition, the intuitive definition that we presented in the last topic, okay, where we consider both sides, okay, from the left and from the right of A. Okay, the definition 2 differs because we only consider or we require X to be less than A only, okay? We did not consider values of X from the right of A, okay? So next is, if we have left-hand side limit, we also have right-hand limit. So similarly, if we require that x be greater than a, we get the right-hand limit of f of x as x approaches a is equal to L. And we write as this one. The limit of f of x as x approaches a from the right. So this means that we consider the values of x from the right of a, then the limit of that is equal to L. Okay? Okay, so this is right-hand side limit. And one example of that is the square root of x minus 2, right? Because we consider the values of x from the right of 2. So left hand and right hand limit. So we have here, sorry, let's erase this one first. Okay. So in this case, we are going to present the geometric interpretation of left hand and right hand limits. For the left hand limit, suppose this is our y is equal to f of x. So this is the graph of y is equal to f of x. And this is our a. Okay. Take note that the limit of f of x as x approaches a from the left. So this is the geometric interpretation. We consider the values of x from the left of a going to a. Okay. Then the function values approaches to that value which is L, and this is what we call the limit. So this is the left hand limit. Okay, so this is the left hand limit. We also have the right hand limit. That is considering the values of x from the right of A. Okay, so again, suppose this is our y is equal to f of x. And as x approaches a from the right, so we use this notation, limit of f of x as x approaches a from the right is equal to L. Okay? As x approaches a from the right, the function values approaches to the value L, which is equal to, or which is our limit. Okay? Or the right-hand limit. Okay? So next is this important theorem. This is very important. That limit of f of x as x approaches a is equal to L. So this is true if and only if the limit of f of x as x approaches a from the left is equal to L, and limit of f of x as x approaches a from the right is equal to L. What does this mean? This means that for a limit to exist, so the limit of the function as x approaches to that value, specific value of x, let's say a, is equal to L, provided that the left-hand side limit and the right-hand side limit, they are equal. Okay, again, the limit of the function as x approaches a is equal to L, provided that the left-hand side limit and the right-hand side limit are equal. If we have a case where the left-hand limit is not equal to the right-hand limit, then we can say that the limit of that function as x approaches a does not exist. Okay? Just like the earlier example or the previous example. Okay. So next is, what's next? This one. Now, sometimes we are not given an expression of a given function. What if we are only given a graph of a function? Okay, for example, this one. Suppose this is the graph of what? G of x. As you can see, G of x is not what? Is not continuous, right? There is a gap here or jump, okay? Also here. So this is, suppose this is our graph of G of x. Now, given this graph, we can determine the values of G at a specific value of x, or we can also determine the limit function or the limit of G as x approaches to a specific value. For example, let's have an example. Example, G of 2. Looking at this graph, what do you think is the value of G at x is equal to 2? So, this means that G of 2 meaning what is the value of G given this graph at x is equal to 2. So, you locate x is equal to 2. This is x is equal to 2, right? What is the value of G at x is equal to 2? What do you think? Is it 1? Is it 3? Or ano? What do you think? So, I give you 1 second to think. What do you think is the G of 2? Now, the G of 2 here does not exist. Why? Maybe you will ask, Mom, there is a circle here with a hollow. Maybe we can say that the G of 2 is 1 or 3? No, it's not 1, it's not also 3. Why? Because it's a hollow circle, which means the 2 is not included here. So in the first place, at x is equal to 2 does not exist. Okay? So in this case, G of 2 does not exist. So we use the abbreviation for does not exist, DNE. Okay? Next is, next. How about G of 5? What do you think is the function value if x is equal to 5? So you locate x is equal to 5. So this is our x equal to 5. What do you think is the y value? I think this one. This is the point. Okay? What do you think is the y value? So we will just estimate the y value here. I think it is, let's say we can have 1.3, for example. Okay? So next is limit of g of x as x approaches 2 from the left. Okay. So first, you have to look at this one. Okay? Kung saan siya pinapapa-approach natin yung mga x values. So using this one, this means that what is the limit of this function as x approaches to 2 from the left? So this is 2, right? Okay? Saan? Diyan. Saan kaya? When we say as x approaches to 2 from the left, so you consider the graph that is formed, okay, with the x values from the left of 2. So as x approaches 2 from the left, so we consider the values of x here from the left of 2, then we have a graph here, right? Okay? So saan siya nag-a-approach? Nag-a-approach siya sa dito. The y value is, this is equal to 3. Okay? So therefore, the limit of g of x as x approaches 2 from the left is 3. How about this one? What is the limit of g of x as x approaches to 2 from the right? Okay, so titingnan naman natin yung mga values of x from the right of 2. Okay? So, meron ba tayong na-form na graph using the values of x from the right of 2? Okay, for example, this one, from the right of 2. Meron ba? Yes. If x is equal to 5, for example, so dito, so as x approaches to 2 from the right, so we consider the value so we can have, saan siya nag-approach? Dito sa 1. The y value. As x approaches 2 from the right it is 1. Okay, so take note that the limit of g of x as x approaches to 2 from the left is 3. The limit of g of x as x approaches to 2 from the right is 1. So what have you noticed? The left-hand side limit, okay, is not equal to the right-hand side limit, right? As x approaches to 2 from the left and from the right. Tama? So, for the continuation, what do you think is the limit of g of x as x approaches to 2? It is what? It is does not exist. Why does not exist? Because again, earlier we have solved the limit of f of x as x approaches to 2 from the left, which is 3. And we have the limit of f of x as x approaches to 2 from the right is equal to 1. Okay? Does not exist since, what's the reason? Limit of f of x as x approaches to 2 from the left is 3. Limit of g of x as x approaches to 2 from the right is equal to 1, which means that the limit of f of x as x approaches to 2 from the left, which is 3, is not equal to 1, right? Which is equal to the limit of f of x as x approaches to 2 from the right. Okay, take note that the limit of f of x as x approaches 2 from the left is 3, which is not equal to 1. Therefore, does not exist. Okay? Okay? So, that's how we find the limit of f of x as x approaches to 2 from the left and from the right. And we were able to determine that the limit of g of x as x approaches to 2 does not exist. Okay, so next, how about limit of g of x as x approaches to 5 from the left? So you consider this one. Again, this is our g of 5, which is 1 point something. So when we consider the limit of g of x as x approaches 5 from the left, tingnan nyo yung graph using, kung ano yung graph na na-form, using values from the left of 5. Okay, from the left of 5. So meron tayong na-form na graph, right? Saan siya nag-a-approach? So, dito, ilalagay lang natin na this is 2. Ito lang. Assuming that this is 2. Okay? Assuming that this is 2, as x approaches to 5 from the left, the limit is 2. How about from the right? Meron ba tayong na-form na graph? Yes, from the right of 5, meron. Okay? Ano kaya ang limit from the right of 5? Using this values from the right of 5, meron tayong graph na na-form. This graph, saan siya nag-approach? Nag-approach siya sa same value, which is equal to 2. Okay? So, what do you think is the limit of g of x as x approaches to 5? Is equal to 2. Using the theorem that we discussed earlier that limit of g of x as x approaches to 5 is equal to L, which is equal to 2, provided that the left-hand limit is equal to L and the right-hand limit is equal to L. And in this case, our limit is equal to 2. Therefore, the limit of this as x approaches to 5 is equal to 2. Okay, so that is how we solve for the function value as well as for the limit of the given function as x approaches to a certain value of x. Okay, so that's it. And for your exercises, I want you to solve this one. I want you to use this graph to solve the following. Okay, use this graph to solve the following. The domain of f, the range of f, and this one, the limit and the function value. Okay. Now, by the way, if we are going to go back to the previous, in this case, okay, in this case, what do you think is the domain of this function? What do you think? What do you think is the domain? The domain in this case, recall, yung domain is the set of x values that can make the function defined, right? Okay? Hmm? So, by just looking at this one, the domain is what? What's the domain? It is negative infinity to what? Values of x that can make the function defined. What? 2. Okay, so negative infinity to 2 union 2 to positive infinity. So it's the domain. Okay? Yeah, that's the domain. Okay, so let's go back to your exercises. I want you to use this graph to solve the following. And take note, for the range of the given function, it's the set of y, okay, depending on the domain, okay? Because the domain is the set of values that can make the function defined. Okay, and since the range, okay, is the set of y's, and the y's depends on the values of x. So you have to take note what's the domain and what's the range, and also the following, this one. You have to analyze. Okay, so if you have answers or comments or questions, you can always write it in a comment section, or you can email that to me directly. Okay, so that's it. Thank you so much. Hope you like this video and hope you learn something from this video. Do not forget to share the learning that you've got from this video. Once again, thank you very much and God bless.